So here we are at target 6. So target 6 is supposed to fix the problem we had in target 5, where we could just overflow the buffer a little bit with a return address and jump straight to the unlock. So how does it do that? Well, let's look at check password. Seems to be our first place to look each time. So we scroll down through here, and so far it's looking like the others. It prompts and then immediately jumps to 4011B2. Here's the second prompt, the try again prompt. And then right after that, at 4011B2, is something that I don't remember seeing before, which is that it is moving the byte, the hex byte 21, to this location relative to the instruction pointer, which the disassembler says is at location 404080, and it has the symbol open char associated with it. So this is something different. Let's scroll on down a little bit and see what happens. So still call validate password, and we test the return result that's in EAX and jump to 4011D0 if it is equal to 0. If it's not equal to 0, we stick a 1 in EAX and jump to 4011E6, and I will bet that that is, yeah, that's down here, the return routines. And so the other place it went was 4011D0, where it adds 1 to this variable that's stored on the stack and then compares it to 2, and that's probably the thing about how many tries you have. And so if you have less than or equal to 2 tries, you jump back and I guess prompt for the password again. Otherwise, it moves hex 78 into that same location and then sticks 0 in the return value, and then it returns. So the behavior of what's stored in OpenChar is hex 21 in the case where validate password returns true, and hex 78 in the cases where it's returned false and you've gone through all your tries, and so check password is going to return 0. So hex 21, according to the ASCII table, is an exclamation point, and hex 78 is an X. So let's take a quick look at OpenLock and see what it does. So we can see that it is all right. So EDI, remember, is the first parameter, and it's a 1 because it's writing to standard out. ESI has a second parameter, and it's supposed to be the address of the data that it's writing, and it is pointing to 404080, which is that open char. And then it's sticking a 1 in EDX, which is a third parameter, which means 1 byte. So it's writing 1 byte that's stored in 404080 and writing that to standard out. So OpenLock is dependent on a data value being stored in that location. And if we view 404080 to begin with, it starts, when the program starts up, it's set to 78. So it's set to what we guess is the don't open the lock, the fail option. So the problem here is, before, what we were able to do from main is we looked at where main jumped to open lock, and we were able to just have check password return straight to this place and call open lock. But now if we overflow the buffer and we haven't entered a valid password, it's not going to have that 21 in this location. So essentially, it looks to me like what we need to do is be able to store a hex 21 at location 404080 and then somehow jump to either 40112B or jump straight to 4011E8. So what we can do here is do another buffer overflow. But I think what we need to do in this case is actually we're going to have to put executable code on the stack. So how do we do that? Well, first we need to know what executable code we want. So let's make an assembly language file. I'm going to call it t6.as. And let me see. I want to move a byte that's hex 21, and I want to move it into okay, I can't. So in the 8086 x86-64, you can't just say move a constant to a memory location. So I'm going to put it in register BL, which is just the very lower part of register RBX. And so it will have the 21, and then I'll put the address of where I want to store it, which is 0x404080, and I'm going to put that in RAX. So register AX has the location where it's supposed to go, and BL has the value that's supposed to go there. So now I'm going to move byte from register BL to, and I put in parentheses RAX, which says go store this byte in the address pointed to by RAX. So that would store it. Now I want to jump, and I don't think I can do an absolute jump, especially not this code is going to be executing on the stack. So sometimes you can do a relative jump that says go 200 bytes back or 200 bytes forward, but the stack is way up there at 7 FFFFFF whatever, and the code is way down here at 4011 something, and I can't do a relative jump that far. But what I can do is I can just put the address of where I want it to jump to, which is what do we say? We either want to jump to 40112B or go ahead straight into 4011E8. Why not just go to 4011E8? So that's 0x4011E8. So I'm going to put that in RAX, and then I'm going to jump to the address contained in RAX. So this is storing 21 at location. It's putting it in a register and putting the address of where I want it in a register, and then I'm storing that register value in BL into the address pointed to by RAX. I'm moving the address I want to jump to into RAX, and then I'm jumping to the address pointed to by RAX. And so those are the instructions I want to execute. So now what I do is I can assemble it. I'm going to call this t6.o, and it's t6.as. And so that it runs it through the assembler that generates the bytecodes, and then I can use obj dump -d to disassemble it. Just disassemble the .o file. And so these are the instructions that I want to execute here. So B321, all this, 8818, and so forth. So I'm going to want to paste these, and what I'm going to do here is I'm just going to put them in an editor. Okay, so I'm going to save this off too. I'm going to make a second copy of it, and now I'm just going to get the bytes. And clear off this end here. join these together so they're all on one line. Okay. Okay, so these are the bytes I would want to put in, but there's a little more work to do. So let's just take a quick look here at we go to check password, and I'm going to put a breakpoint here, and then I'm going to run, and then I'm going to step through the bits that are setting up the stack. So now when I go to memory and hit S to go to the stack, this is the stack. And so this 21140 down here, remember this was what we attacked the last time to tell it to return to the open lock. But now what we want to do, we're going to put code on the stack, and so this is actually going to have to return to somewhere on the stack, probably this D010. So what we can do is go back to this, and we're going to have to count. Let's see. Again, we had to fill in 40 bytes the last time in order to get to this return address. So we're going to have to put in these. Look, okay, how many are there here? 1, 2, 3, 4, 5, 6, 7, 8 is up to that. 1, 2, 3, 4, 5, 6, 7, 8 is there. And that's the next set of 8. And then this. And so I need to add I need to add that, and then I need to have it return to let's see, if it's 10, D0, FF, 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 7F, and then the rest are going to be zeros. So this might be what we want. I'm gonna make a copy of it so I have it to work with in case in this format. Okay, because what I want to do is put this all on one line, and then copy it so I can just paste it in. All right, so let's go down here to right before we call validate password. Whoops, I hit J too many times. All right, I'm going to do right before here, I think. I'm going to break here, and now I'm going to go hit continue, and I'm going to enable hex input, and then I'm just going to paste this in here. And hit enter, and go back over here, and now let's look at the stack. So we see the B3, 21, 48, blah, blah, blah. So let's just see what happens there. Failed to validate password. It's going to jump. It's going to add one. Oh, look at this. It's going to add one. Okay, that may be okay because this is in the midst of stuff we don't care about. So and now it's going to go back up here, and it's going to prompt again for the password. So I'm going to have to paste that in again. So I'll do that. Hit enter. And now we're back here. And we're going to validate the password again. And it's not good. We're going to... Oh, so look at this. We're going to get stuck here in sort of an endless loop because every time we're overriding this variable for how many times we've been through the password loop. So what I want to do is go back over here to this, and so starting at this E0, there's oh, it's the one right below it. So let me go up to the first line here and delete it, and then make another copy of this. All right, and now this is where it's incrementing the count of how many times we've been through the password validator. So what we want to do is, I'm sure 10 will be fine as a value there. So what this means is it'll increment it and compare it with 2, and then it'll say, no, that's not the right password, or that you've exhausted your tries. And so, yeah. Now I'm going to copy this again. And I'm gonna hit continue. All right, now when I paste this in and pop back over here, we're gonna put the 21. We're gonna call validate password. Password wasn't valid, so we're gonna jump down here. We're gonna add 1 to this. Now see, it's 11 where it had been 0. And now it's going to compare, and it's going to say, nope, it's not less than or equal to. It's going to move 78 into 2E9F, into 40, 40, 80. And it's going to put 0 in EAX, and it's going to return. And so hopefully it's going to return to 7FFFFFD010. So if I hit N, look at that. The instruction pointer now points to 7FFFFD010. And I can't really, the disassembler doesn't know how to disassemble that because it's really stack data. So we don't know if this is going to work or not. All I can do is I'm going to hit continue and see if it does work. And sure enough, the unlock succeeded. So this is a sort of your classic buffer overflow attack. Before the operating system started adding features that make it harder to do this, and we'll take a look quickly at another target. There's a target 8 that you can't really solve, but we'll look at it and see why you can't solve it.